Very good morning students, welcome to my channel Miracles of Math. So in this lecture we will be learning relation between arithmetic mean and geometric mean. In the previous classes we have already learned what is arithmetic progression, arithmetic mean, geometric progression, geometric mean, and now we'll see what is the relation between arithmetic mean and geometric mean for two given numbers. See here, let us take two numbers a and b. What is arithmetic mean for these two? I will represent with a. Arithmetic mean of these two, if you remember, this is a plus b by 2. What about the geometric mean? Geometric mean of two numbers ab is root over ab. Geometric mean is root over ab. So, is there any relation between these two? What I'll do, I will try to find what is the value of a minus z, and at last you will understand why I am starting like this. A minus g, what is a? A plus b by 2 minus g, what is g? That is root ab. So, any relation, see here, take LCM, a plus b minus 2 root ab by 2. Correct? What I'll do, I'll write this a as root a whole square. I'll write this a as root a whole square. So, this is root a whole square plus root b whole square minus 2 times of root a root b by 2. So, any formula you can identify a square plus b square minus 2ab, which is nothing but a minus b whole square. So, this final answer, this final step will give you as root a minus root b whole square by 2. Tell me one thing, square can it ever be negative number? Square of a number, can it be a negative? It can be 0 when those two numbers are equal, but always it is positive. So, this is always greater than 0, and in one case where both the numbers are equal, we can say it is equal to 0. So, arithmetic mean a minus g, which is always greater than or equal to 0. So, the relation between arithmetic mean and geometric mean can be written as a greater than g, or we can say am. Arithmetic mean is always greater than geometric mean. Arithmetic mean is always greater than geometric mean. So, that is the relation between arithmetic mean and geometric mean. Okay, let us try to bring one question with this. How can we apply this one? See, let us take two numbers. Let us take two numbers x and 1 by x. X and 1 by x. We want to find the minimum value of x plus 1 by x when x is greater than 0. That means I am talking about positive numbers. We are talking about positive numbers. Students, geometric mean, if you remember, geometric mean is root over ab. So, if you have a negative number in between them, inside that one, okay, it's not defined. It's not defined for real numbers. So, when you're talking about real numbers, always we talk that about two positive numbers. So, in the same way, when I'm having x is greater than 0 positive number, I want to find the minimum value of x plus 1 by x. Like 2 plus 1 by 2, 3 plus 1 by 3. So, every number gives me some value. I want to check what is the minimum sum I can get. What is the minimum sum I can get? So, see here. So, there are two numbers x and 1 by x. What is the arithmetic mean of these two? It is x plus 1 by x by 2. Arithmetic mean is always greater than or equal to its geometric mean, that is root over x into 1 by x, root over ab. Correct. So, these two gets cancelled and becomes 1. So, x plus 1 by x is always greater than or equal to, this is 1 and this is 2. We will go here, this is 2. So, x plus 1 by x is always greater than or equal to 2. The minimum value x plus 1 by x can take is equal to 2. That is also when these two numbers are equal. That means x and 1 by x should be equal. That means the number x is 1 as well as 1 by x is also 1. So, 1 plus 1 will give you the number equal to 2. Only in this case, the minimum value is 2. And for all the values, however small or however large it is, always the sum will be greater than 2. Alright, let us see more applications on this one. See here, let us take one question. if x, y, z are distinct positive numbers, we have three numbers x, y, z which are distinct positive numbers, then prove that x plus y into y plus z into z plus x is always greater than 8 times of x, y, z. 8 times of x, y, z. So this is what we need to find. Okay. So if you carefully observe, we have two numbers here, two numbers here, two numbers here. We'll individually take and we'll apply am greater than gm. So x plus y by 2 will always be greater than root over xy. Correct? So I have a relation here, x plus y is always greater than 2 times of root xy. In the same way, when you're taking the same relation for y and z, y plus z is greater than 2 times of root over yz. For z plus x is always greater than 2 times of root over xz. So now what we can do, we have three inequalities. What we can do? Okay, so you simply product all these. So x plus y into y plus z into z plus x is greater than or equal to, the product of these three is greater than or equal to product of these three. 2 into 2 into 2, that is 8. Root x into root x becomes x. Root y into root y becomes y, and root z into root z becomes z. So this is the relation which we want, and we cannot keep equality here because in the question it says that distinct positive numbers. It was mentioned in the question that it is distinct positive numbers. So equality will not come anywhere. So no equality, no equality, no equality. So that's the relation we want. It may be equal. It will be equal when all the three numbers are equal. When all the three numbers are equal. Alright, let us see one more question. Find the minimum value of 3 power x. Find the minimum value of, see here. Find the minimum value of 3 power x plus 3 power 1 minus x. Find the minimum value of this one. So once again, whenever you want to find the sum of minimum of two numbers, minimum of sum of two numbers, without anything you can apply arithmetic mean greater than geometric mean. So what is am? 3 power x plus 3 power 1 minus x by 2, am should always be greater than or equal to gm, that is root over 3 power x into 3 power 1 by 3 power x. Correct? 3 power 1 by 3 power x. So 3 power x gets cancelled. So 3 power x plus 3 power 1 minus x is always greater than or equal to 2 times of root 3. Yes or no? So the minimum value it can take is 2 root 3 and it's always greater than that. 2 root 3. Yes, that's the correct answer. Yes or no? It's very simple using arithmetic mean and geometric mean. Let us see some more relation between arithmetic mean and geometric mean. See, when two numbers are given, it is easy to find its geometric mean and arithmetic mean. But what if the case is reverse? When arithmetic mean and geometric mean are given, then how to find the values? How to find the both the numbers? So that's the concept we'll be discussing here, and then with that we'll stop this lecture. See here. To find the numbers when the geometric mean and arithmetic mean are given. To find the numbers when geometric mean and arithmetic mean are given. Okay, let us take those two numbers as a and b. First of all, before going to actual procedure, that is arithmetic mean is a plus b by 2 and geometric mean is ab, root over ab. We'll see that later. Tell me one thing, what is the equation with a and b as roots? We have, in quadratic equations we'll be learning that. Okay, the equation formed with a and b as the roots is x square minus a plus b times of x plus ab equal to 0. This is the equation when two numbers a and b are there. If those two are the roots, that equation will be this one. I'll just give you a small example. If 2 and 3 are the roots of some quadratic equation, how to find the equation? X square minus sum of these two, that is 5x, plus product of these two, that is 6, equal to 0. So if you solve for this one, you will get x is equal to 2 and 3. That we'll learn in quadratic equations. So coming to this concept, x square minus a plus b into x plus ab equal to 0. So what is a plus b? If you can find a plus b is 2 times of arithmetic mean. Okay, so x square minus 2 times of arithmetic mean into x. I'm representing that as a. 2 times of arithmetic mean into x plus ab is actually g square. ab is g square plus g square is equal to 0. So if you can frame this equation when arithmetic mean and geometric mean are given and try to solve the roots of this, those two roots will be both the numbers a and b. Let us take one small example. Find two numbers whose arithmetic mean is 34, given arithmetic mean is 34 and geometric mean is 16. Geometric mean is 16. So we need to find both the numbers. So we have an equation. Whose roots are a and b, the numbers, and what is the equation? X square minus 2 times of a, that is 2 times of 34 into x, plus g 16 square is equal to 0. So let us try to solve this equation. X square minus 2 times of 34, 2s, 35 2s, 70, it should be 68x, plus 16 is 256, right? Okay, so we need to factorize this one. How can we factorize? 256 actually 16 into 16, or this is 4 into 16, that is 4 into 64. Okay, 256 I can write as 4 into 64 and the sum will give you 68. I think this is easy. Okay, see how I'll write this one to solve. So we can write this as x square minus 4x minus 64x plus 256 equal to 0. So x into x minus 4 minus 64 into x minus 4 is equal to 0. And x minus 4 into x minus 64 equal to 0. So you get the numbers as x equal to 4 or x is equal to 64. So the numbers are 4 and 64. Whose geometric mean is 16 and arithmetic mean is 34. You can cross check that. Okay, let us assume that you don't know this formula, you don't know this application, you don't have any knowledge of this process. So then what to do? Nothing to do, just do the basic process, whatever you want, whatever you know. So arithmetic mean of two numbers is a plus b by 2. A plus b by 2 is 34, so a plus b will be 68. Correct? And what is root ab is 16, so ab is equal to 56. We have this relation, right? So simply we need to find a and b from here without any equation. We don't have any equation, we don't know anything. So how to solve this one? So you have two numbers with you, a and b. Try to bring what is a minus b value, then we can directly solve these two to get the value of a and b. How to get a minus b? There is a relation a minus b is equal to, a minus b whole square is equal to a plus b whole square minus 4ab. You can check that. Just expand these two, we'll get that. Alright. So what is a plus b whole square? 68. Okay, so it is 68 whole square minus 4 times of ab, that is 256. So now we need to find the value of this one. Is this difficult? Maybe. Let us try. Why not? Okay, so let us find what is 68 square. 68 into 68. You can also write 70 minus 2 also. That will be more easy. But okay, whatever it is. I did 64. 6 8 48. 48 plus 6 is 54. 6 8 48. 6 6 36 plus 4 is 40. So it is 4 12 6 4 6 2 4. 4 6 2 4 minus 256 4s. 6 4s 24. 5 4s 20 22. 5 4 2s 8 9 10. So it is 1024. So cancel these. Subtract these two. What you will get? A minus b. A minus b whole square is equal to 24. 24 gets cancelled. 46 minus 10, that is 3600. A minus b whole square is 3600. What about a minus b? A minus b is equal to root over 3600, which is 36 is for 6. So it is 60. Easy. A minus b is 60 and a plus b is 68. Can you solve these two now? Yes or no? A minus b is, I'll write once again. So a minus b is 60 and a plus b is 68. We have that. So just add these two, b gets cancelled. If you add these two gets cancelled. So 2 times of a is equal to 6 and 6, 128, where you will get a is equal to 64. And substitute back here, you will get b is equal to 4. So the numbers are 4 and 64, the same thing we got here. So it is your wish whether you want to proceed in this way or in this way. And just as we came till here, what happens if you cannot factorize here? What happens if you cannot factorize? That we actually we will learn in quadratic equations, but just I will say you what happens. If you cannot factorize, use the formula. The formula is x is equal to, for the equation ax square plus bx plus c equal to 0. Okay. The roots of this equation is x is equal to minus b plus or minus root over b square minus 4ac by 2a. So if you cannot factorize, you are supposed to use this formula. One with positive and one with negative, you will get two different solutions. That will be both the numbers. Clear? So this is all about arithmetic mean and geometric mean, the relations and applications. So we'll stop it here and we'll continue in the next lecture.